we had a question in class about the arcsecant derivative, and so I wanted to talk about that a little bit. The question was, why do we get an absolute value in the denominator? So we'll go through our process of taking the derivative of, we're being asked to find dy dx, where y is arcsecant of x. So we do our rewrite, secant of y equals x. We make our right triangle. Secant is hypotenuse over adjacent, so we have x over 1, and we use Pythagorean theorem to find the third side. Now we can take the derivative of both sides implicitly of the secant y equals x equation, and we get secant y tangent y dy dx equals 1. Solve for dy dx, and we get dy dx equals 1 over secant y tangent y. And a little rewrite just to make it cleaner and easier to see on the triangle. We rewrite it as dy dx equals cosine y times cotangent y. So if we go up to our triangle, cosine y is adjacent over hypotenuse, that's 1 over x, and cotangent y is adjacent over opposite. So we get the 1 over the square root of x squared minus 1. And in our work, we do not get an absolute value to pop out, but we see that if we ever check the form of our answer, that there is an absolute value. So let's look and figure out why that is. So for the function y equals arcsecant of x, we have a graph of it here, and the domain for this function is x is greater than or equal to 1, so it's defined over here, and x is less than or equal to negative 1, this way. The range goes between 0 to pi halves and pi halves to pi. And I should have parentheses and not square brackets. Let me fix that. All right, so the range is from 0 to pi halves, not including pi halves, in union with pi halves to pi. We have a square bracket on here. Okay, so if you look at our graph, you will see that the slope on this graph everywhere is positive. And we need to think about what we can do to our derivative function to make sure that our slope always comes out positive. So what we notice is that slope is always positive, so if x is greater than 1, so if we're over here, then the derivative would be the positive of 1 over x root x squared minus 1. And if x is less than negative 1, then we're dealing with negative x values, and we would have to put a negative out in front to account for the positive slope in that region. And one easy thing that we can do to account for the ambiguity that we get with a positive and negative is we can simply put the absolute value around the x in the bottom, which will take any negative value, make it positive, and if we have a positive value, it will keep it positive. So we can handle that plus and minus by simply putting an absolute value around the x in the denominator. This same explanation, or very similar explanation, works for arc cosecant. So that's how we end up with dy. Okay, dy dx equals 1 over absolute value of x times the square root of x squared minus 1. So hopefully that clears that up. And if you have any further questions about that, let me know. But generally, when you derive your derivative of arcsecant, we just need to remember after we go through our algebra that we need an absolute value around that x to account for the positive slopes for arcsecant. All right, hope that helps.